Hello there, Mr. Sutton here, bringing you the IM3 Honors 4-4 lesson on quadratic systems. In this one, we're going to solve linear quadratic and quadratic-quadratic systems. And as a real-life application, we'll figure out when a camera is going to be taking pictures on an amusement park ride. Before we do systems of equations with quadratics involved, though, pause the video and see if you can solve this system of linear equations. All right, let's see how that went. So with linear equations, we have lots of ways of solving the system, either with substitution or elimination, and we could graph these as well. I'm going to use substitution here for my part. So I look here and I see that y equals 3x minus 5 and y also equals negative 3x plus 7. Well, if y equals both of those things, then that means 3x minus 5 and negative 3x plus 7 must also equal each other. So basically we're using the substitution method here, plugging in 3x minus 5 for this y right here. And now that we have only one variable in the equation, we can solve for x. So let me add 3x over to the left side to get 6x. And then let me add this 5 over to the right side to get 12. Dividing by 6, we get x equals 2. And then you have to actually plug this back into one of these equations to figure out the value of y. I'm going to go with this first equation. So 3 times 2 minus 5, that's going to give me the value of y. So 6 minus 5 gives us 1. And then at the very end, because when you solve a system, you're actually finding a point where two functions intersect on a graph, we write the point out. So that's going to be the point 2, 1. So hopefully you don't run screaming from the problems in this lesson, but you may run screaming from this ride. The Tower of It's Six Flags theme park, shown here, launches riders up a tower like so, whee, and lets them fall back down. The height in feet of the rider after t seconds is given by this formula here, h equals negative 16t squared plus 130t. So this is based on gravity and velocities and things like that. We've seen formulas like this before. So now there's something else in play here. A camera is taking riders' pictures on the way up and back down. So here's a little button for the camera right here. So somebody gets launched up, we take a picture on the way up, and we take a picture on the way back down. And the height of that camera is given by this h equals 18t plus 96 formula. What we want to know is when should the camera be programmed to take a picture, and how high will it be when the riders are at those times. So basically we want to figure out a t value and an h value that are the same when you plug them into both of these formulas. We want to solve a system. So here we go. Woo! Oops, that wasn't supposed to happen. So here's the actual math problem that theme park problem was the inspiration for. We're trying to solve this system, graphically figure out where these two functions intersect, and notice one of them is a parabola, quadratic, the other is a line. So we're going to start this just like we did with the linear system. We're going to use either substitution or elimination to solve for a single variable. In this situation, since these both equal h, we can again just substitute one of these equations for the h in the other equation. So I'm just going to plug negative 16t squared plus 130t in for the h right here. And just like that, I now have a single equation that has only one type of variable in it. So I can go ahead and solve for that variable. So on this one, we don't have just squareds and constants. We have these linear terms as well. So that tells me I want to move everything over to the left and solve either by factoring or quadratic formula. So let's do that. Let's keep negative 16t squared on the left. And with the linear terms, I'm going to keep 130t over here, but let me subtract this 18t from it. That gives me a positive 112t. And then let me subtract 96 to get it over there as well. So now we have 0 on one side. And this is not looking very appealing to try factoring or even use quadratic formula on. But if you look closely, negative 16, 112, and 96, they're all divisible by a single number. 16, or actually you could take out negative 16. I mean, 16 goes 6 times into 96, and 112 is only 16 more than 96, so 16 goes into 112 7 times. So we can actually divide all of this by negative 16. If we do that, we've got just t squared for that first term,
112 divided by negative 16 is going to give me negative 7, and it has a t there as well. Negative 96 divided by negative 16 gives me positive 6, and 0 divided by 16 is still 0. So this looks like it's going to be a little bit easier to solve by factoring. Pause the video real quick and just finish solving for the t values here. All right, so this one we can ask what multiplies to 6 and adds up to negative 7. That would be negative 1 and negative 6. So I can do t minus 1 and t minus 6 equals 0. And then just figuring out what zeroes out each parentheses, solving by factoring, we see that t equals 1 or t could equal 6. Great. So those are the times when the camera should be taking a picture of the rider. Now what? Well, we haven't really solved the whole problem. We also wanted to know how high the ride was at the times we're taking these pictures. What's the h value at these times? So whether you're dealing with t's or h's or x's and y's, once you find one variable, for each x value or each input value, you have to plug in to find the y value that goes with it. So for 1, we're going to plug that into one of these equations. Now, if you had a choice, which equation looks like it's a little bit nicer, I'm going to go with the second one here. There's no squareds and there's only a single place to plug in t. So I'm going to say h equals 18 times 1 plus 96. And that's just 18 plus 96, which is going to be 114. And we can actually make a point out of that. We can say 1 second, comma 114 feet. So let's write our points with the correct x's and y's together on this. And there's another reason it's important to write out a point once you have an x and a y value. And that's because just writing these things out, it's not obvious to the reader which x values go with which y values, since there's more than one of each. So that's why we write this point to really keep it together. And now for this other one, I'll just plug 6 into the same equation. So we have 18 times 6 plus 96. That's going to be, let's see here, 6 times 18. That's going to be, let's see, 60 plus 48, 108 plus 96. And that's going to be 204. So we can write the point 6 seconds, comma, 204 feet. Here's another example for you to try out. Pause the video and see if you can do this one on your own. All right, so for my first step, I substituted 10 minus 2x for the y over here. And then, let's see here, let me add the x squared over to the left side. And I'll keep the negative 2x over there, just getting everything on one side because it's a quadratic with a linear term. And now let me keep the 10 on the left and subtract this 9 from it. So that's a plus 1 over there, and that whole thing equals 0. Well, this looks like I ought to be able to factor it. Factors of 1 that add up to negative 2, well, that would be negative 1 and negative 1. So I can just write x minus 1 quantity squared equals 0. So that means that x equals 1. And plugging that back in, doesn't really matter which one I choose. I'm going to plug it in up here. So we've got 10 minus 2 times 1, or just 10 minus 2, which gives me 8. And, I mean, there's only one x and y value, but I like writing points. So let me write 1, comma 8. Now, just in terms of what's actually going on, this is saying that this line and this parabola are intersecting at only this one point. So that's a possibility. We saw before that you could have intersection at 2 points as well. Can't really intersect at more than 2 spots with a line and a parabola, but either of those are possibilities. And it's also possible, of course, that they don't intersect anywhere. All right, we'll do this one together. So just like before, we use a little substitution to get one equation with just x's. So we can write 6x minus 10 equals all this other stuff here. And let me get everything over on one side. I'm going to move everything over to the right this time. Only I'm going to write the results on the left because I hate having like a 0 equals something. So we'll keep the 5x squared where it is. And then 7x minus the 6x over here gives us just 1x. And then I'll move this 10 over here to be with the 3. Negative 3 plus 10 gives me plus 7. And I'll write the 0 over on the right instead of the left because it's just weird having 0 equals. All right. So this does not look like it would be all that fun to factor, if it even can be factored. So I'm just going to go to the quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. There it is again, our friend the quadratic formula. Plug in stuff in. we've got negative 1 for the b value, plus or minus the square root of 1 squared, minus 4 times a times, so a is 5 there, times c value of 7, all over 2 times the a value of 5. So this is going to be negative 1 plus or minus, now let's see here. This is 1 minus 140, which is negative 139. And then we have a 10 downstairs. Now, simplifying this, we can take out an I, and it's at this point that we should be getting kind of suspicious. Remember what we're trying to do on this problem. We're trying to find where things intersect on a graph, on the x and y axis, not on the real imaginary axis. So you can't intersect at an imaginary number. It just can't happen. It's not real. So for that reason, we're just going to say there is no solution to this one. Imaginary solutions don't count, and we don't have to plug this back in to find an imaginary y value. We'll do one more problem just for fun. Pause the video, try it out. All right, so let's plug in x squared minus 4 for the y over here, again using substitution. Now this one's a little different than the others we've seen today because you'll notice there are no linear terms. There's no x to the first power. So whenever we have that situation, as we've seen, we can just solve by isolating the squared x and square rooting both sides. So to do that, let me add 20 over to the left side just to get the constants together. That's 16 on the left. And if I subtract x squared just to get that with the 2x squared, that's 1x squared over on the right. Square rooting both sides, we see that x is going to equal positive and negative 4 because we're square rooting an equation. Remember, we need the plus or minus in there. And now let me plug in 4, negative 4 to get the y values that go with them. So if I plug in 4, and I'm going to use this equation right here, that's going to give me 4 squared minus 4, so 16 minus 4, which is actually 12. So that means I have the point 4, comma 12 as one of my two solutions. And now if I plug in negative 4 to the same equation, well, negative 4 squared is also 16, minus 4 is still 12, that hasn't changed. So we also have the point negative 4, comma 12. So there we are. So that's it for systems of quadratic equations. Hope you enjoyed the ride. Till next time, Mr. Sutton signing off.